We'll take a look at another example of calculating and interpreting a confidence interval. And this example is going to involve estimating the proportion of households in San Bernardino County that are multi-generational. This example is similar to 9.1 numbers 25 to 30 in the homework. The Inland Empire Economic Partnership recently conducted a study to estimate the population proportion of households in San Bernardino County that are multi-generational. And we'll make a note that multi-generational indicates that the household's members span several generations. So, for example, the grandparents may also live with their grandchildren and their parents. The Inland Empire Economic Partnership obtained a random sample of 800 households in San Bernardino County and determined whether each household was multi-generational. They found that 322 out of the 800 households were multi-generational. In Part A, it says obtain a point estimate for the population proportion of households in San Bernardino County that are multi-generational. The point estimate for a population proportion is the sample proportion, p hat. So that's that same formula, x over n. In this case, 322 over 800. It comes out to 0.4025, or converting that to a percentage, that's 40.25%. Part B says verify that the requirements for constructing a confidence interval about p are satisfied. So the requirements for a confidence interval are based on the formula itself. The formula for a confidence interval for a proportion is this, and the margin of error in particular is this formula. And those formulas are derived from the sampling distribution of the sample proportion. And if you're interested, if you want more information about how they derive the formula or about the sampling distribution of the sample proportion, you can go to pages 11 to 13 in the Chapter 9 slides. So here are the slides. And if you're interested, it goes over what the sampling distribution of the sample proportion is and how that relates to how they derive the formula for the actual confidence interval. For the formula, for this formula to be reliable, that sampling distribution must be normally distributed. And that's what introduces the requirements. So in order for that sampling distribution to be normally distributed and for this formula to be reliable, the first requirement is that the sample must be a random sample. That's almost always an important requirement. And in the problem, it does state that this sample is random. The second requirement is what they call the normality condition. And it turns out that this formula, n times p hat times 1 minus p hat, if that is more than 10, the rule of thumb is that that ensures that the distribution is approximately normal. And it's good to check this. N is 800. The p hat we just calculated is 0.4025 times 1 minus 0.4025. When you multiply that, it comes out to 192.395, and that is more than 10. That's true. It is true. And so the normality condition is met. The third condition is that all trials must be independent. And one way to check to see if trials are independent is to verify that the sample size is less than 5% of the population size. or you can write it in these symbols, that n, lowercase n, is less than or equal to 0.05 times capital N. The sample size is 800. The population size of households in San Bernardino County, so capital N, is not provided in the problem. But that's okay. We can not use it for now. We'll plug in the 800, plug in 800 into this inequality, and solve for capital N. Divide both sides by 0.05. And when you do that, you'll get 16,000 less than or equal to n. Or another way of saying that is that capital N must be greater than or equal to 16,000. And what that means is that this inequality is true as long as the population size of households in San Bernardino County is more than 16,000. And it seems reasonable to conclude that there are more than 16,000 households in San Bernardino County. So, yes, we can say with confidence that this inequality is true, and therefore the trials are independent. So those three requirements are met, and that means that we can go ahead and construct confidence intervals, and the confidence intervals will be reliable and accurate. Part C says construct and interpret a 99% confidence interval for the population proportion of households in San Bernardino County that are multi-generational. There are different ways of calculating a confidence interval, and as always, I'm going to show all the ways, and it's up to you which method you prefer. You don't have to necessarily use all of these methods. The first method I'm going to show is using a formula and using a table. So if you're using a formula, the first thing you want to do is calculate the margin of error. We'll use that margin of error formula. P hat is the sample proportion, that's 0.4025. N is the sample size, that's 800. The only other value that we would need is the z sub alpha over 2, the critical z value. And remember from the first example that that z value, it represents the cutoff for the middle of the standard normal distribution curve. In this problem, they want us to make a 99% confidence interval. And so that means that this time, the z sub alpha over 2 is the cutoff for the middle 99% of the curve. And to find out what z would be, we can use table 5b. Remember, it's at the bottom of table 5. Here's table 5b. Look up 99% confidence, and the z value for that is 2.575. Those are all of the values that are needed. We'll plug them all in. Plug in the z, the p hats, the n, and it comes out to 0.0446. So the margin of error is 0.0446, or as a percentage, that would be 4.46%. And again, keep in mind that this means that we're going to have high confidence, 99% confidence, that the true population proportion could be as much as 4.46 percentage points higher or lower than the point estimate of 40.25%. The last thing, now that we have the margin of error, is to calculate that confidence interval. Confidence interval is p hat plus and minus the margin of error, so 0.4025 plus and minus 0.0446, and the lower bound comes out to 0.379, the upper bound comes out to 0.4471. And that's our result. And remember that you can also write it in terms of percentages, because we're estimating proportions, which are percentages. Another way to calculate this confidence interval is by using a graphing calculator. when you are using a calculator, you'll use the function called 1p on the Casio calculator, or if you have a TI, you'll use the function called 1propzin. On the Casio, you would take these steps, go to your menu, select the stat window, then select the option called enter, which is F4, then select Z, which is F1, and then finally select 1P, which is F3. And when you get there, it'll ask you for the confidence level. We'll put 0.99 for 99% confidence. And it'll ask for the X and the N. The X was 322, the sample size was 800. And then you put execute, and then it will give you the result. Kind of similar for the TI. You go to the stat button, go over to the tests, scroll down and find the function called 1propzint, and then enter 322, 800 for the X and N, and then enter the confidence level of 0.99. And so either way, you should get a result that is this. This result is a little bit different than what came out when we used the formula. And that's okay. That's just due to the fact that we had to round off some values when using the formula. So we have this result. Here's the interpretation. You want to say something like this: we are 99% confident that the population proportion of households in San Bernardino County that are multi-generational is between 35.78% and 44.72%. And when you give your interpretation, remember that you can reword it in different ways, but you want to include three things. You want to mention the confidence, you want to mention what you are estimating, which is the proportion in this case, and then of course you want to mention the actual interval. Alright, in the next video we'll take a look at more parts to this problem.